Hi, I'm Glenn Bell. I'm a senior principal at Simpson, Gumpertz & Hager, and I'm also the newly installed president of the Structural Engineering Institute of ASCE. With me here today is Dr. Andrew Myers. Andy is an associate professor in the Department of Civil and Environmental Engineering. And we're here today to talk about collaboration in research between academia and industry. Andy, welcome.
Thanks, Glenn. It's an important topic, and I appreciate the invitation to talk about it with you.
Thank you. So Simpson, Gumpertz & Hager and Northeastern have done a lot of research together, a lot of applied industry research. What's your take on when that type of industry collaboration is desirable, and what does industry bring to the table in research?
Yeah, I think engineering research to some extent is applied by its very nature, and so it has some degree of use inspiration, and you're building something on it. And so I think collaboration with industry is able to bring timely relevance. They're able to bring an eye to commercialization, and I think that can be a magical combination, especially when you combine it with the kind of more long-term thinking that the academic perspective can have with the immediate relevant thinking that industry can have. And so it can lead to really amazing projects.
Great.
So Glenn, how do you see it?
I really think that more collaboration between industry and academia in research is going to be really key going forward. And the reason for that is that we work in an environment that's really rapidly changing, and we expect that change to accelerate. And so we need to be able in industry to bring new ideas, new and better ways of doing things into practice more quickly. And this is where this partnership between academia and industry can really work. I think a part of what brings industry to the table is identifying what are the most pressing needs that we need to work on so we can work better in a more innovative manner. So let's talk about some of the joint research projects that SGH and Northeastern have worked on over the years. Describe one of them to me.
Yeah, so I just got a new project. It's led by SGH. I'm the sub on it, along with Mott MacDonald and Offshore Design Engineering from the UK. And it's a project that's supported by the Bureau of Ocean Energy Management. So they are a part of the Department of Interior for the United States, and they're charged with the responsibility of managing offshore leases for harvesting energy. So a lot of oil and gas leases, but more recently they've been charged with managing the leases for offshore wind energy industry. And so I'm really thrilled that SGH, like me, sees a really important role for civil engineers to play in the offshore wind energy industry. I mean, you think about what it is. It's large infrastructure, broadly distributed, with a deep impact to the public. I mean, that's what civil engineers do. So this particular project, we're looking at the interaction of corrosion and fatigue, and how it's going to impact the lifetime of offshore wind structures. That's a huge part of the design because the longer that structure can operate, the more electricity it can generate, and then the more return that structure will provide to the public. And so it's a really important topic. It involves a ton of disciplines. It involves metallurgy, it involves offshore loading, it involves structural analysis, it involves design, it involves chemistry in terms of corrosion. It's a really great project, and I think that it's a nice partnership because SGH brings broad disciplinary expertise, and then I'm able to kind of bring my experience in this particular domain and a view to some of the fundamental problems that I think are acting as barriers to advancing this industry.
Right, and we're really excited to be involved in this project with you as well. It's an area where many people may not think structural engineers might go, and I think it speaks to the future of sort of broadening our skill set and the way we apply our skills to solve problems. We're really working here on a really important initiative for society, bringing clean energy to the fore in very important ways. So we're excited too.
I think that's right. And whenever I'm talking to students, civil engineering students, I always make sure to bring this up as a possibility for where they might use their skills. I think it's going to be an important industry for the United States, and I think it's going to be an important industry really soon.
Right. Yeah. Andy, talk to us a little bit about the Stress Lab. This is the off-site lab that Northeastern has in Burlington, Massachusetts, I believe. What's its purpose? What do you do there?
Yeah, so it's a large-scale hydraulic structural testing laboratory. It's been in operation for 7 or 8 years now, and actually that whole campus, our whole satellite campus there, has a lot of infrastructure, and all of it is centered on industry-academic collaboration. So there are systems in place that make it easy for corporations to protect their information if they have things that are confidential that are part of projects. So in the Stress Lab, We are interested in designing new and resilient systems. We're interested in developing and assessing new materials and new sensors. I've done work, like I mentioned before, on looking at new manufacturing processes and seeing how those affect structural performance. And I think I just really love doing structural testing. I mean, I just think it's such an important part of our profession. I mean, modeling is an essential part of our profession. It lets us take the results of large-scale experiments, which are expensive and specific. I just think it's so important to any kind of new idea or new innovation to be truly credible and believed across our community. I think it has to rely on structural tests to demonstrate the credibility of an idea.
You know, we can get very enamored with our very exotic finite element analyses and so forth, but periodically you've got to go back and validate what the computer's telling you with real-world test experience. I think it's critical. I actually, as an engineer, I think it's kind of fun to sort of pit the machine against the testing and see where the results are aligning and where they don't align. You learn a lot from that, but it's really critical to validate. We believe it's so much in it that at Simpson, Gupperts, and Hager that we have our own laboratory there. We're kind of unusual for a design lab, design company rather, to have our own laboratory, but we break things in our lab. We come to Northeastern to break things and physical testing. We're really very much aligned with your thinking there.
So I was curious, I know that you have some experience working with Northeastern on a couple of projects that were centered at the stress lab. I was wondering if you could tell me about that.
Yeah, one that I really am excited about, and we have completed it, is working on a very specific problem in trying to deal with problems that are thermal bridges in certain types of construction. And specifically, these are issues when we have steel structures that have attachments that sort of penetrate the insulation layer of the structure to support, say, an exterior wall or maybe an exterior canopy or rooftop mounted equipment. So the common problem there is that we take a steel structure and attach it with steel elements to the outside, and that bypasses all of the insulation that we put in the wall system and provides a heat bridge, if you will. And we know that reduces the energy efficiency of the structures very well. So it's a practical problem. There had been before this no really industry guidance on how a designer could deal with that. There were a number of strategies that involved putting insulating layers in steel connections and so forth, but no guidance for how to drive these structurally, how to design them structurally, or really what sort of strategies and particular details were good for thermal insulation. So we brought a lot of technology together on this, both solving the thermal problems, that is looking at various strategies, which one were sort of optimal in reducing this thermal bridging, but also how could structural engineers design these connections with thermal insulators put in place. So we did a lot of thermal modeling together, heat flow modeling, and we did a lot of testing, particularly out at the stress lab, to look at various, for example, bolted connections with these insulating layers. And the result of that, I'm really proud of and has been quite popular, is a design guideline that will help engineers develop optimal thermal break details in steel buildings. Another sort of similar energy-related project that we worked out together is design for deconstruction. The idea behind this is that when a lot of structures reach the end of their useful life, they are simply demolished, the parts are thrown away. And what we know from that is, from a sustainability perspective, we are throwing away a huge investment in embodied carbon, and we need to reduce that. We need to look at the entire life cycle from cradle to grave of the materials. So the idea behind design for deconstruction is actually to design structures to be more readily disassembled at the end of their useful life. So we can take the parts and pieces and use them in the next building or for another purpose. So we work together on a system that is actually a combination of precast concrete planks, fairly traditional in its basic component, on a steel frame, and devised a system of clamps rather than welds and so forth to assemble these, and came up with a system that at the end of its useful life is a structural frame and plank system that can be taken apart. So there's design guidance there. We can go out and use these, design these reconstructible buildings right now. And I think it's really interesting in the three examples that we just talked about They're all energy related, aren't they? Two in terms of energy and carbon conservation, the other in terms of clean energy performance. These are important issues that we're working on to help solve big societal issues.
Yeah, I totally agree. Whenever I look at the environmental impacts of the built environment, I mean, the numbers are just staggering. And so I think that the civil engineer just has a really important role to play in understanding those environmental impacts and working to minimize them to the greatest extent possible.
There have been various estimates made, but the most reliable I've heard of is that about 40% of the carbon that we release into the atmosphere from human activity is due to the design and operation of the things that we design and build, the built environment. So there's a lot of opportunity to make gains here. So other than the collaborations between my company, SGH, and Northeastern, what other experiences have you had with industry-academic collaboration? How have they worked out?
Yeah, I can think of two projects come to mind. Both of them were funded by the National Science Foundation as part of their GOLI program. So GOLI stands for Grant Opportunities for Academic Liaisons with Industry. And so it's a program that requires, it's a fundamental requirement of the research project that you have an explicit collaboration with industry. And so I've had two awards through that program. One with a startup company that was developing a new clever manufacturing process for making wind turbine towers, and another with a huge international wind turbine manufacturer, Vestas, out of Denmark. And so in the first project, it was this startup company. They had a really clever idea for a manufacturing process for making wind turbine towers, which are thin-walled tubes, and thin-walled tubes are sensitive. Their performance is sensitive to imperfections, which is sensitive to the manufacturing process. And so they had all sorts of structural questions about how their new manufacturing idea would relate to structural performance. And so we did a series of imperfection measurements to understand their imperfections, to understand their manufacturing process, and then we did shell finite element analyses along with large-scale structural tests at our laboratory. And so it was a really nice kind of combination of industry with this new manufacturing process combined with structural engineers who were answering questions for them, kind of combining structural analysis, structural experiments, and manufacturing in order to advance this new idea.
That's really interesting, and I'm not sure how well known the GOLI program is in industry. Maybe it's better known in academia, I'm not sure, but I'm curious about how that particular project came about. Was that an initiative from you in Northeastern, or did it come from the manufacturer, or was it some dialogue that led to that? How did it come about?
Yeah, so I mean, just in my own personal networking, I came across this startup company. They were out of Boston. They're in Colorado now, but they were out of Boston at the time. And he was telling me his idea. It was compelling. I was really enticed by the potential of what this idea could do for making turbine towers cheaper and also being able to make them in the field where you don't have to transport them, so you can make them really big. It was a really exciting idea, and he had some fundamental questions that were directly related to my experience and my ability to test in the laboratory. And so it was just a natural partnership. And so I knew about this program. It's a program that is advertised mostly to academics. And so I asked them about it. They were very interested to pursue this, and we were successful.
So I guess one of the lessons learned there is in sort of enabling or encouraging more academic industry collaboration. The academics have to be networked in actually to industry. That's how it came about in your particular case. You saw a need there because of your networking.
That's exactly right. Yeah, I think it's all about the conversations. You have to have the conversations between industry and academia. And the ideas just like naturally fall once you have the conversations. And if there's a program, a funded program that caters to that type of thing, it can lead to really successful partnerships.
Fantastic.
And so then this other project is a more recent one. It's a collaboration with Vestas, the Danish turbine manufacturer, and Johns Hopkins University. And here, again, we're kind of coupling structural engineering with manufacturing. And so they make full-scale wind turbine towers in their tower factory in Colorado. And they have all sorts of questions about how their manufacturing process relates to imperfections, residual stresses, and how those imperfect tubes, those imperfect wind turbine towers, then perform in the field under really complicated loading. So it could be flexure combined with torsion. That's a particularly important load combination for which the science really is kind of lacking. There isn't good design processes in place for that kind of situation. So we're going to go to their factory, we're going to measure imperfections, We're going to do shell finite element analysis as well as structural tests at the laboratory scale and at the desktop scale to try to sort out these issues so that they can make more efficient tubes, stronger tubes, and make them faster as well.
That's fantastic, and you're engaged directly with manufacturing right there. Really
That's right.
Interdisciplinary work.
Right.
So Andy, many in industry have opined that we need more practical needs-driven research in our industry in order to drive the profession forward. Do you agree with that view?
Yeah, I do. I mean, I think both types of research are really important. The kind of open-ended, long-term, basic research, as well as the immediate, near-term, practically relevant commercial research.
No, I agree entirely about that. I do believe we need to have a balance between long-term or academically, theoretically research and more shorter-term, deeds-driven practical research as well. So I'm really happy to see this coming together. There really has been, I think, a void, or a pause in bringing enough practical needs-driven research to industry. And we have been sort of in industry looking around for solutions to this problem because, as we talked about earlier, with the rapid change in the world right now, the need to innovate, the need to be efficient, the need to provide so much infrastructure to serve society, we have to innovate, and we have to be able to bring that innovation into practice a lot sooner. So one of the programs I'm really excited about, I think you're familiar with, is the Charles Pankow Foundation. And what I'm really intrigued with is their model, where they really have a panel of experts that look around and are plugged into the industry, and they ask themselves, what are the most pressing problems that we have to work on? What does industry need? And they will only fund research projects that are validated by that question. Not a simple answer, they really go through a rigorous process to validate it. And then the other part of their mantra, if you will, is that the results of the research have to be immediately implementable in industry. And I think that is filling perhaps a void that we had further. Pankow Foundation has really become very popular. Their popularity actually has outstripped their available financial resources right now. So there's been a lot of discussion about how we can proliferate that model, both by leveraging Pankow, but also by developing their skills in different areas.
Do you see opportunities to kind of expand Pankow's reach, to find other funding opportunities related to that topic?
Yeah, I think there are a lot of opportunities for doing that. I actually serve on Pankow's board now, and we've had a lot of discussion about how we can do that. And one of the areas, I think the thermal brake strategy program was a good example of how this can work, where the Pankow funding and maybe some NSF funding and other maybe more traditional sources of research are leveraged. And the question that we ask is, who are the key stakeholders in this, and how can we go and engage these key stakeholders who have an interest in solving a problem? So in the example of the thermal brake strategies program, we had funding from NSF, we had funding from the American Institute of Steel Construction, leveraging Pankow money, and those are sort of obvious and more traditional sources. But then we also reached out to the suppliers of the thermal brake equipment and materials that we could use, who clearly had an interest in solving this problem. So we engaged an industry organization of producers of insulating products and individual companies to leverage that. So the question is, who are the stakeholders and how can we get them to contribute to the research? That's proven to be a pretty effective strategy.
I think it's so important to have research programs that are requiring these type of partnerships, because when the programs are requiring the partnership, the conversations will happen and the ideas will flow from there. And I think if we're looking for kind of more immediately impactful, relevant ideas, they have to be incentivized with a program that awards projects on those topics.
Yeah. And part of what makes this work is the process is very nimble. As an idea comes together and a research proposal comes together, you don't go through the traditional sort of long cycle of sending out RFPs and trying to get responses and so forth. There's a lot of very active, dynamic discussion amongst potential stakeholders to try to bring the research money together. And Pankow's found a way to do that very nimbly. So something I'm really interested in exploring with you is the question of intellectual property. And this becomes an issue in an industry, the construction industry is not terribly strong necessarily on pursuing IP. But the more that we go out to get contributions from key stakeholders, the more their interests come in mind, and the ownership of the intellectual property then rises to the head of the agenda. What's your view on IP? What's your experience with it?
Yeah, that's a really good question, and to me, I think it kind of cuts two ways. So I think a lot about how IP influences the cycle of innovation, and whether does it help to accelerate it or does it slow things down? And I can sort of see it doing both. So in the one sense, being able to protect your intellectual property is an essential part to being willing to invest resources into innovating new ideas.
Right.
So you with the promise of being able to protect your innovations and to make profit off it down the road, I think firms and institutions and individuals are far more willing to make investments up front into innovation. And so I think IP helps with that.
Right.
But then on the other side, I think about these projects. So big projects are great learning opportunities for the whole community. We can learn so much by measuring things from our work and by seeing honestly, what went really well and what didn't go well. And then if we share those results broadly, there could be such fast innovation happening when lots of folks have access to that information. But the way things work usually in projects is that information is held very tightly by the design team and by the developers. And so I think that can be a hindrance in some cases.
No, it can. It's an interesting dilemma because the promise of IP is an incentive for people to invest. It's a source of funding that may not be there otherwise. On the other hand, we often have a strong incentive as an industry to share things in a sort of open source thing. I think the answer probably lies in picking the right project opportunities that are going to be more closely held, where there is acquired intellectual property, and others where it's really in the industry's interest to share things more open source.
Yeah, I think that's right. And one area I've seen is the government can play a role there. In public funded projects, they can have requirements that data be measured and that projects be assessed through the measurement of data and that be shared broadly. And so I think that's one role that we can get this information, we can disseminate it broadly, and we can all learn from it to make things better and accelerate innovation. So I'm curious to hear your thoughts about what you think are some kind of new topics of research for structural engineers.
Yeah. Broad general areas, what has really gone to the top of our agenda in structural engineering relatively recently, we've been talking about it for a while, is our issues with sustainability and carbon emission. And I think we have a lot of work to do there. The industry needs a lot of help with that. That's going to be big. Another big thrust for the Structural Engineering Institute and the industry is to advance performance-based design, because we really believe that is the key to creativity and value and being able to do better performing structures that are more creatively designed. Eliminating waste in construction processes is another area that's really important. We know from a lot of research that there's a lot of waste and inefficiency in construction processes. So I would say those three areas, generally topically, need to get a lot of attention in the upcoming years.
Yeah, so I'm really interested in expanding the topics that structural engineers think about when they're doing research projects. So the topic that I've been focusing on, as we've been talking about, is offshore wind energy. I think that there's a lot of contributions that structural engineers can make to that industry, a lot of important contributions to get that industry going in the United States. I also think there's big opportunities in machine learning, in structural sensing, in development of new sensors and smart structures, in using data to better measure the performance of structures and have that inform our designs. I think there's lots of opportunities, and I'm really interested in expanding them for structural engineers.
Fantastic. Andy, your views of the broadness of our roles and the innovation are really inspiring. I look forward to working with you some more, and thank you so much for your time here today.
Thanks a lot, Glenn. It was a pleasure.